Hey Calculus, we are ready for slope fields 7.4, and we've kind of worked through problems. Like, we're pretty well versed in this, so understanding a slope field is pretty elementary. It's just a concept that we have to cover. I felt like it was easiest if I just went to the answer key, because if we did this separation of variables like we've done, we already touched base on this plus c. Now what we call is this plus c problem is the general solution of dy dx. But if you notice in this problem, we don't have a visual, we don't have an initial condition to explain exactly what x and y value is hit by this graph. And I thought it'd be just easier if I just talked about the plus c. Means that there's an infinite number of solutions, as the shape of the graph of f of x would be the same no matter what the c value is, just shifted up or down. So just think about how many different graphs have the derivative where you'll get x minus 1. 1/2 x squared minus x plus 20. 1/2 x squared minus x plus 3. All of them have the same derivative of x minus 1. So that's sort of where we're going with this. And we can visualize it using slope fields. So let me actually teach that part. That's just explaining why we have an infinite number. And if I went too fast, feel free to pause, write down what you are thinking, and then go on from there. So when you're tasked with a slope field, they usually give you the graph. And it's usually not this many points. But basically what it boils down to is we can create any number of points on this graph. Like this is the ordered pair 1, 0. And they usually don't on the AP test. They will not ask you to do 20 different points. But this is an x and a y value. And you need both. Now in this problem there's only an x in the derivative. So what I'm doing for this point is I'm plugging in 1 in for x. So what I'm doing is I'm doing dy dx at the specific ordered pair 1, 0. Well, 1 minus 1 is equal to 0. So what we do is we make a tiny line at that point that has a slope of 0. And notice it's just like a little, I don't know, think of a tiny piece of rice or something like that we just put right there. Now if I extended that line on, it would continue with a slope of 0, but don't do that, just like a tiny sliver. And I'll just do one more at x equals 1 because the work will be the same, because there's no place to put in a y value, so it's still 1 minus 1, so this slope is still 0. I hope you understand that even though it's 1, 2, this will still be a slope of 0. Slope of 0, slope of 0, slope of 0. But maybe do your next one, dy dx, at the ordered pair 0, 0. Again, there's only an x value to plug in, and 0 minus 1 is negative 1. So at this point, I'm going to put my tiny piece of rice as if it had a slope of 0. So imagine for a second it would keep going, it would hit over here and over here. And I hope you're starting to realize that all of these will have a slope of negative 1 when x is 0. And I could do, maybe I'll even put like 0 comma y, because the y value doesn't matter in this specific problem. So if I did one more, dy dx, let's do at x equals 2 with any y value, because again there's no y to plug in. 2 minus 1 would give me 2, or 2 minus 1 gives me 1. So that means that all of these x equal 2, 2, 0, 2, 1, 2, 2, all of them have a slope of 1. And notice if I were to continue this line down, it would hit this point. Now if you're curious how they grade this on the AP test, basically they're looking at, are the slopes of 0 look like they're zeros? And do the slopes that are positive look like they're positive? Do the slopes that are negative look like they're negative? So I'm going to hurry up and finish the next one, because we did all of these x equal negative 1. Negative 1 minus 1 would give me negative 2. So I would make this a little bit steeper, and I'm trying to make it hit that point. as if it had a slope of -2. Slope of -2. But anyway, they're a little bit steeper. And then x equals -2 will even be steeper than that, because it should be -3. Oh, that was a pretty bad one right there. -3. And so the whole premise of this, I'm going to do this in a light color, is let's say we knew in an initial condition like the curve hit at 1, 2. Well, if the curve hit at 1, 2, well, it would be a horizontal tangent right there. But as I go to the right, notice I get a positive slope. And as I go to the left, I have this negative slope. And it sort of matches up with the quadratic equation. And because I'm not very good at drawing these, I'm going to jump to the answer key on how. It doesn't look like he's very good at drawing these either. But we have an infinite number of quadratics that could have this derivative. And that's all I wanted to point out. And they show quadratics, they show parabolas in this specific problem. If you need more work, he does. You don't have to do all of these. And typically on an AP test, I've seen like 12 points max that they'll ask you to find. So this was sort of an obnoxious problem, if you want my opinion. So here's another one, but notice now we have an x and a y value. So when I look at the ordered pair like 0, 0, well, 0 minus 0 will give me 0. I like to have a bolder color than that. But sometimes what I'll do is I'll just pick points where x equals y. So like dy, dx at the ordered pair 1, 1. Because then it makes perfect sense to me. Oh, well, 1 minus 1 will give me 0. And that's true for any value where x is equal to y. So at 1, 1, I'll get 0, a slope of 0. So make a horizontal tangent there. At 2, 2, I would get a slope of 0. At -1, -1. At -2, -2. And then I'll just think about, well, what would happen if I had, I don't know, 0, 1. So if I did dy, dx at the point 0, 1, well, that tells me that x would be 0, y would be 1. Well, 0 minus 1 would give me -1. So I would imagine I'm drawing a diagonal line with a slope that's negative. And then I like to think about, well, where else would I get that same slope? I would suggest, if you're still confused, do as many as you can. But the next one I'm thinking is, what if I did -1 minus 0? Or this one would be -2 minus -1. And there's definitely a pattern that happens. I don't know if you can follow my pattern. But then maybe switch over to, well, what if x was -2 and y was 0? Well, if x was -2 and y was 0, it would be a steeper negative slope. And -1, 1. -1 minus 1 would be a steeper slope. And by the way, if you are confused by how I'm finding these at all, please write down your questions and get back to me. And I think you're starting to, well, I really don't know, but what happens is that these are happening, they're the same slopes diagonally. So this one's a steeper negative, a steeper negative, a steeper negative, and then an even steeper negative, steeper, and even steeper than that. Whereas when I get to values like dy, dx at, I don't know, x equals 1 and y equals 0, well, 1 minus 0 gives me +1. So here I'm getting a positive value, a positive value, a positive value. See how they're happening on the diagonal? So feel free to try to work through as many as you can until it makes sense to you. So if we knew a point on this curve, let's say we knew a point was right here, was the initial condition. Well, then as I move to the right, so this should be a horizontal tangent, but as I move to the right, it starts to increase. And I don't know how fast it would increase like this, but to the left, I get this kind of steeper pretty quickly. So this is what this graph would look like. or maybe it hit right here. Okay, well, to the right and then to the left. Okay, so this is definitely a different type of question than what we had on the previous problem. And just sort of as a reference, oh, he didn't give any initial conditions. He just kind of went right into it. Yeah. And so you're not always tasked with graphing a sample answer, but if you see it on a multiple choice, or sorry, on a free response question, if it shows up, because we are limited on the questions they can ask, they might say graph a sample answer if it went through the ordered pair -1, 2. So then what you would be tasked with is making sure that you had a negative slope here. So basically this would be a negative tangent line as a slope of -2, but as I go to the right it gets less and less steep, and as I move to the right, you would have some sort of positive slope that way. So you can be ready for that. Here's a way that they stick this on a multiple choice question. Now, on a multiple choice, they won't ask you to explain your reasoning, but basically what it boils down to is that you need to pick out points and see if the slopes match. For instance, I'm seeing at all of these values, 1, 2, 3, I believe this is supposed to be -1. So at all of these x equals -1, it doesn't matter what y equals, you should get a slope of 0. So let's say we pick this one, which looks like to me -1, 5 is the ordered pair. Well, does -1 times 5 give me a slope that's 0? No. To me, it makes more sense that you could factor out an x plus 1 somewhere in the problem to get x equals -1 works. For instance, you could factor out a y in this problem, and x plus 1, you would get a slope that has a 0 at x equals -1 no matter what. And if you're still confused by that statement, then we'll try this next one. -1 times 5 is -5 minus 5. Well, that didn't give me a slope that works. Whereas this one does work, because if I did -1 times 5 plus 5, I do get 0 there. The problem with this one is if you factor it out, it would have been y plus 1. So again, -1 times 5 minus 1 does not equal 0. That would give me -6. So that answer doesn't work. Now that I've whittled this down to a couple good options, because E also works, you might want to find another time where you have horizontal slope fields. So like if I look at 5, 0, well, if x equals 5 on this one, I do not get a horizontal tangent there. So that's also a bad answer, whereas that being able to factor out the y is definitely helpful. I don't know if my answer key, he does the same thing, is he notices where our slopes are positive or our slopes are negative, but it looks like overall he did the same thing I did. He looked for where these tangent lines are 0 and then factored out. I think I'm going to stop the video here. Write down any questions you can. How about this? How about you try through this next one, because I'll just keep this video short. Pause the video, try this problem, create your slope field, and then you have to do things from the previous unit, the previous section, 7.3. And come back to the video, and I'll just share the answer key right here. So you can see that the slope field. Part B, here's this answer, and then part C, there is the final answer there. So you pause the video. So this is just going to be a one video lesson, I believe. And I'll just share the last answer. Pause the video. And then here's the answer to B. Pause, and I don't have